Hello. In the previous lesson, we examined the results of cross products to determine whether two ratios are equal. There is another method for this. Now, I will talk about that method. To determine whether the given two ratios are equal, we will try to equalize the denominators of the given ratios. Friends, how will we perform this operation? Let's look at our first example. In our first example, one denominator is 16 and the other is 4. I immediately think, where do the numbers 4 and 16 meet? If I take 4 times the number 4, 4 times 4 equals 16. This means the denominators are equalized. Therefore, when I expand both the numerator and the denominator of my first ratio by 4, I obtain the following. 4 times 3 12. 4 times 4 16. What was on the other side? 12 over 16. So, as a result, weren't the numerators and denominators of these two results equal? It is then I can say that these two ratios are equal. So I have learned this. To understand whether two ratios are equal, I can look at the cross products or check if there is equality between the numerator and denominators of the result by equalizing the denominators. Let's look at the other example. Who do we have in our denominators? 5 and 2. Where can I equalize 5 and 2? I can equalize them at 10. So, let's do this. Let's expand the part with 5 by multiplying both the numerator and denominator by 2, and the part with 2 by multiplying both the numerator and denominator by 5. What do we get? 2 times 3 is 6 over 2 times 5 is 10. Is it equal? 5 times 7 is 35 over. 5 times 2 is 10. What was needed when we equalized the denominators? The numerators also needed to be equal to each other, but unfortunately, they are not equal here. That's why I say these two ratios aren't equal. Let's look at our last example. Our denominators are 10 and 15. What do I think right away? I am thinking about what number I can use to equalize 10 and 15. We can equalize them at 30. Friends, so if I expand the part with 10 by 3 and the part with 15 by 2, of course, how was I expanding? In a ratio, you cannot multiply just the denominator by a number. You can multiply both the numerator and the denominator, right? Similarly, if I multiply both the numerator and the denominator by 2, 3 times 8 is 24 over 3 times 10, 24, 3, 30, 10, 30. I wonder if it's equal. 2 times 12 is 24 over 2 times 15, which is 30. Yes, it's equal. Then there's no problem. I can say that these two ratios are equal to each other. Again, what is this method we learned? To understand the equality of ratios. When the denominators are equal, do the numerators also become equal? If they are equal, I say these ratios are equal to each other. If they are not equal, it says these ratios are not equal. And we conclude the matter. See you in the next lesson.